up, guys, and welcome back to my YouTube channel. I'm here with my favorite pup, Gizmo. Say hi to Gizmo. All right, well, he seems really unamused, so I'm going to go ahead and put him down so he can go do pup things. And we're going to go ahead and get started. Alrighty, guys, so like I said, we're going to go ahead and jump into what we need to get to today. So what you guys are going to need for my classes, you're going to need your blue notes packet. Just looks like this. And we're going to go ahead and turn to day 3. Now, if you don't have a notes packet, that's okay. Feel free to take out a scratch sheet of paper just to take some notes on. These notes are completely optional. They're just there to help you. So I'm going to piece out in this little box here. We're just going to go ahead and get started. So let's go ahead and take a look at the warm-up. So you guys with Miss Perrick were looking at arithmetic and geometric sequences and deciding how to classify them. So I want you guys to hit pause and go ahead and try the warm-up on your own. Okay, welcome back. So let's go through this warm-up and and if you have any questions, you can just feel free to shoot either one of us an email. Okay, so with your Unit 1 family, answer the following questions. Here is the sequence that we are given. Question A is saying classify the sequence as arithmetic, geometric, or neither. Now, if I'm going down each of these, I'm noticing a pattern of going down for each time. That tells me that the sequence is arithmetic. Okay, because subtraction is the same thing as adding a negative number. So now we know it's an arithmetic sequence, and now we have to find a sub 3, a sub 6, and a sub 12. Okay, so the third term in the sequence is -2. The sixth term in the sequence, that's not really explicit for me, so I'm going to have to extend the sequence, subtract another 4, and that's going to get us -14. Okay, and a sub 12. I don't really want to do that right now just because I'm going to have to extend that sequence, and I really don't want to spend too much time doing that. So we'll come back to that. Okay, given the sequence B sub n, we have 8, 4, 2, and 1. Now over here, I'm noticing that I'm dividing by 2 each time, which is the same thing as multiplying by 1/2. So that tells me that this sequence is geometric because we've got repeated multiplication. And then same thing. The second term in this sequence happens to be 4. The fifth term in the sequence is going to be, I have to extend it one more. So 1 times 1/2 is 1/2. Okay. And then B sub 10 is going to get a little annoying. So I'm going to pass on that real quick because guess what today is all about? Ding, ding, ding. By deriving a formula. So let's go ahead and talk about the explicit formula for generating an arithmetic sequence. An arithmetic sequence. Okay, so we have a sub n equals a sub 1 plus d times the quantity of n minus 1. Now, what the heck do all of these letters stand for? Well, a sub n is the value that we're looking for. So I'm just going to call this the value sought, or the value that we seek. A sub 1 is going to be your first term. This D here is going to stand for common difference. And the N is the term number. Okay, now if you look at this, this looks very much like a linear equation, which makes sense, right? Because you've got repeated addition or repeated subtraction. So it makes sense that it looks a little bit like a linear equation. So let's put it into practice. So here's a sequence that we've got. And it says find the common difference. So because we're told find the common difference, that kind of tips me off that it's an arithmetic sequence. Because for a geometric sequence, we've got a different word for what we're multiplying over and over again. So the first term in the sequence is going to be 3. The common difference, I'm noticing this sequence is going up by 4. So the common difference is 4. Now from there, we're just going to go ahead and plug in the numbers where they belong. So our formula is going to be a sub n equals a sub 1. Now a sub 1 is 3 plus your common difference, which is 4, followed by n minus 1. Now just so that we're clear, I'm just replacing the values that we figured out into the appropriate place in our formula. So now we're going to use our formula to help us find the sixth term in the sequence. So if I'm trying to find the sixth term, I'm going to copy down my formula, but instead of writing n, now I'm going to plug in the number 6 because I'm looking for the sixth term. We're going to follow order of operations. So 6 minus 1 is 5. And so when we're following order of operations, we have to do multiplication first. 4 times 5 is 20. 20 plus 3 is 23. So that tells me that the sixth term in our sequence is going to be 23. Now, if I'm looking for the 25th term in the sequence, we're going to follow something very similar, except instead of plugging in n, we're going to plug in 25. Follow order of operations again. Okay. 4 times 24 is 96. 3 plus 96 is 99. So the 25th term in our sequence is going to be 99. All right, so if you're following along, go ahead and turn these notes to the back. All right, so now let's do this a little bit differently. This time I give you the arithmetic sequence equation. And so if I give you an equation, we can go ahead and pick apart some important pieces of information. So for example, it's an arithmetic sequence because it follows the structure of the arithmetic sequence formula. So yes, for the reason that I just said out loud. And then if we answered yes, find the first two terms. Well, guess what? Our first term, G sub 1, is actually in our formula. Save yourself some work, guys, and pull that right out from the formula. So your first term is going to be 27. If you can't remember that, that's okay. You can totally plug 27 in for n right here, but it might be in your best interest just to pull that information out. Okay, now if we're looking for the second term in our sequence, one thing we could do is we could follow the pattern. We could follow our common difference, which is minus 2.8. Okay, so 27 minus 2.8 is 24.2. Okay, now we can double check our answer by plugging in 2 in for n. So we've got 27 minus 2.8. We're going to plug in 2 for n minus 1. Okay, and then if you plug that into your calculator and follow order of operations, you will get 24.2. Okay, now let's go ahead and practice finding the third term. So we're going to plug in 3 in for n. So I get 27 minus 2.8 times 2. Oh, I'm sorry, 2.8, not 28. So we get 27 minus 2.8 times 2 is 5.6. And then 27 minus 5.6 is 21.4. Okay. All right. So now if we look at an arithmetic sequence a little bit differently here, we've got our first term, and then we have the fourth term. So we don't know yet what our second and third terms are, which is a little problematic because the first part of this question is asking us to fill in the blanks of the values. But fear not, that's what this video is going to teach you to do. So the first thing we want to do is count the number of jumps from the first term to the next known term. So it takes us a total of 3 jumps to get from 3 to 5.7. The next thing we want to do is we want to find how far apart those numbers are. So we want to find the distance from 3 to 5.7. So I'm going to do 5.7 minus 3, and that gets us 2.7. Okay, so I know that the distance between 3 and 5.7 is 2.7, and it took us 3 jumps to get there, or it's going to travel 2.7 units over a span of 3 jumps. So if we divide that, 2.7 divided by 3, that gets us 0.9. So that means every jump I'm increasing 0.9. So this is plus 0.9, this is plus 0.9, this is plus 0.9, and so on and so forth. So this blank is going to be 3.9. And then the following blank is going to be 4.8, 5.7, 6.6, whoops, and 7.5. So yeah, that's how you figure out how to fill in those blanks. Now let's switch gears a little bit and talk about generating an explicit formula for a geometric sequence? I hope this is ringing a bell for you guys because this structure looks very similar to what we just finished studying. Exponentials. Ooh, I should really take a look at that cough. All right, so A sub n here is going to be very similar to what A sub n stood for in our arithmetic sequence. So A sub n is our value sought. A sub 1 is still going to be your first term. Okay, now your R, a lot of people want to say that that's your common difference. So you're on the right track, but we're actually going to call this our common ratio. Okay, and that's the number that we're multiplying over and over and over again to figure out the next term in our sequence. N still stands for your term number. Okay, so if we take a look at example 4, it's asking us for the first term in this new sequence, which is 2. Upon further inspection of the sequence, I'm noticing that I'm multiplying by 4 each time. Whoops, not 2. Okay. So our common ratio is multiplying by 4. And then we're just going to plug in those values. So our formula is A sub n equals A sub 1 times R to the n minus 1. So I'm going to plug in 2 in for A sub 1. And I'm going to plug in 4 in for R. So what your formula is ultimately going to end up looking like is 2, 4 to the n minus 1. Okay. Again, it's an exponential sequence. Okay, cool. So now we can use our explicit formula to help us find the next couple terms. So if we're looking for the 6th term, we're going to plug in 2 times 4 to the 6 minus 1. Okay, and then we're going to follow order of operations. So order of operations tells us, let's take care of our exponents first. So 6 minus 1 is 5. Then we want to take care of 4 to the 5th power. Okay, so 4 to the 5th power is going to get you 1,024. So we really have 2 times 1,024. 2 times 1,024 is 2,048. Okay. If we're looking for the 20th term in your sequence, very similar. We're going to plug in 20 in for n. So we have 2 times 4 to the 19th power, because 20 minus 1 is 19. And then 4 to the 19th power is going to get you a really big number in your calculator. You're going to see something like 2.748 e to the 11th, okay? And what this is basically saying is that your calculator is saying this is a really big number. I'm going to give you the answer in scientific notation, okay? So when we go ahead and multiply by 2, your final answer is 5.49. I'm not going to go beyond that, times 10 to the 11th power. That's what that E stands for, is times 10 to whatever power. We're using scientific notation here. Alrighty, guys, so thank you for watching this video. If you have any questions, feel free to reach out or attend our office hours. Don't forget to like, subscribe, and comment down below.